Hi everyone! In the video today I want to show you how to install R in RStudio and start using them for the very first time if you haven't ever used them before. So when we want to install these programs, the first thing we have to understand is that R is the actual programming language, and RStudio is a development environment in which the R language can run. So it'll kind of clean up your interface, make it a bit more manageable, make it more usable. And then there's some other things that like the RStudio team has done in the larger context of R that are super useful. But in general, RStudio is just the environment in which the R programming language runs. So if you've never installed R before, that's the first thing you're going to want to do. So we're going to go to the R project, which is at cran.r-project.org. And CRAN is for the Comprehensive R Archive Network. And then we are going to be taken to this page where we have several different download options. Download R for Linux, download R for Mac, or download R for Windows. Since I'm on a Windows PC, I'm going to click there. And then this window will look a little bit different depending on your installation, right? If you're installing it on Mac or on Linux. But here I get this handy little link to say install R for the first time. So I'm going to do that. And then I'm going to click on Download R 4.0.2 for Windows. And this is going to install the most recent version of R. And if you're installing R for the first time, that's the one you're going to want to run. Like if you've been running R for a while, there might be reasons why you want to use a slightly older version of R. But in general, if you're getting started, you want to use the most recent version. So we're going to go ahead and save that file. Might take a second to download. So we're going to be asked, some standard questions in the course of this installation. So setup language is English. That's fine. There's the GNU General Public License. You can read through all that if you want to with your installation. But I'm just going to click next. Right, then it will set up a program folder for us, and it will save these things in an R folder under Program Files. So that's fine. And then in general, we're going to just do the default installation and take everything. So then, yeah, again, we will say no for startup options. We don't want to specify anything, so we'll just accept the defaults. And then it will ask whether we want to create a start menu folder, which we do, so we'll say yes. Then, select any additional tasks. So you can create a desktop shortcut if you want, or a quick launch shortcut. I'll leave those turned off. You can turn those on if you want. But for the registry entries, those are checked by default, and so we'll leave those defaults as turned on, and I'll say next. Then it'll go through a relatively fast installation, and one of the nice things about R being pretty fast and efficient is that although like base R can do a lot of things, one of the nice things about it is that people have built packages that you can add on to your R installation in order to gain additional functionality. So installing base R gives us access to a lot of different things, right? But there are additional R packages that we might want to install as time goes on if we want to do certain specialized analyses or certain specialized, graphs or interactive figures on the web, right? There are lots of different things that we can install because R is incredibly powerful and flexible in terms of the scope of what it can do. So we'll get into actually installing those packages in a second once we actually have RStudio installed as well. But for now, it looks like our setup for R is complete. So I'm just going to say finish. And now that R is installed on my computer, I can actually go and download RStudio. So we can go to the RStudio webpage. And RStudio actually, hosts a number of things. But we're just going to go to products, and then we're going to go to our RStudio. And we have a few different versions of RStudio. Since we're running this on like a home PC, I'm going to select RStudio Desktop. If you wanted to actually install RStudio to run on a server, so you could work on it remotely, you would choose the RStudio server. But we're going to select RStudio Desktop. Then it will ask us which edition we would like, and I'm going to take the open source edition rather than RStudio Desktop Pro. Now there are some limitations to this, right? We don't get priority email support or some of these other features, but it is free, which is a tremendous advantage. So I'm going to go ahead and say download RStudio Desktop. Then I will scroll down. It'll show me a few different options again in terms of what I want to install. But then I will say download. And then RStudio, the website, is smart enough to kind of scan your machine and determine what operating system that you're running, and it will prompt you with its recommended installation. So for mine, it says download RStudio for Windows. Otherwise, you can install other versions or download other versions of RStudio from down below if it doesn't prompt you with the correct one up here. But let's go ahead and do download RStudio for Windows. Again, it'll save this installation file. Might take a second. and we'll go through the RStudio setup. So let's click next. Choose a local installation, right? So we're gonna just create an RStudio folder under Program Files. That's fine. Start menu folder. Yep, we'll put that under RStudio. It'll take a little while to install because there are a few different things that it has to go through in terms of the installation of RStudio. Great, but once that's all installed, we can complete the RStudio setup. So I'll just click Finish. And now, if I actually go to my Start menu, right, and I scroll down to my programs, I should have an RStudio folder. So I can click on RStudio. So when you start RStudio for the first time, you should have something that looks kind of like this. Your background, might be a little bit different than mine because you'll have different color presets than what I have set. But you'll start with 3, possibly 4 windows. But usually I think you have these 3 windows when you first start it up, which show us the console, the environment, and sort of a plot and other tools window down here. And we're going to talk through what each of these things do. But what I actually want to do first is open up the 4th of the sort of canonical windows that we're going to use, which is opening an R script file. So I'm just going to click on this button for New File, and then I'm going to click on New R Script. And what we'll get is a new script file, which is up here, up above the console window. So if any of you have used something like MATLAB before or different development environments for Python, this probably looks pretty familiar, but I'm going to talk you through what each of these different components does. So the script file is where we actually write code, and then we can save it so that we can access that code for later. And the script window is pretty handy because it allows us to, write out our code, but also insert comments. So for instance, if I put a hashtag, and then I can say, this is a comment, the hashtag tells R that that's not an active line of code. That's just a note to myself. And you can see that it's just kind of grayed out. However, if I actually want to write an active line of code, so for instance, I could say something like create a variable called X, and I'm going to assign to it the value of 2, I could say X is assigned the value of 2, and then I could run that code either by pressing the Run button up here or pressing Control-Enter on my keyboard. And what you'll see is that both of these pieces of code from my script file actually get run down in the console. So both of those pieces of code where the actual are stored in the script file, but where the actual computation happens is down here in the console window. So this is where code is actually being run, and it's also where we're going to see any warning or error message that comes up if we have problems in our code. The other thing that we can see is we have this global environment where it will show us objects that we have created during the R session. So in this case, we just created an object called X that takes the value of 2. If I were to change this, so let's go back and I'm going to reassign X the value of 3, you can see that that code then runs down in the console window, and X takes the value of 3 up here now in my global environment. So this is where any information that we're creating is going to be stored in the short term. But it's important to remember that it's only being stored there during the R session, right? This is essentially being stored in your computer's working memory, not its long-term memory. So if we really want something to be saved on our computer outside of the R session, that will take some extra steps, and we'll have to, save that file independently, which is something we'll talk about in later videos. But now I can change this, right, to show you some other things in the global environment. So for instance, if I wanted to create a more complicated value of X, so let's say X takes the values of, I'm going to say C, 1, 2, 3, 4, and 5. So now X is actually going to be a vector that takes 5 different values. So when I run that code, you can see again, it comes down here in the console window, and the value of X is updated in my environment, where X takes is a sequence of numbers, 1 through 5. And this C is actually a function inside of R that tells it to concatenate these values. And so concatenation means it's storing these values as a vector. In sort of spreadsheet logic, you can think about this is that X is now a column. It's a column of 5 numbers. And I could create another column that goes along with that. I'm going to say Y. And I'm going to create a column or another column of 5 numbers here. So let's say that Y is rather than numbers 1 through 5, let's show another function here. Let's say that I want 5 randomly distributed numbers. So I'm going to use the rnorm function for random normal distribution. And you can see that R norm, it prompts me with this helpful little yellow ribbon to tell me kind of what arguments this function takes. But it says there's n, there's the mean, which by default is set to 0, and there's the standard deviation, which by default is set to 1. So I can say, all right, well, let's make it n of 5, so it's the same length as x. I'm going to say my mean is equal to 0, because I want this to be a standard normal distribution. And I'm going to say that the standard deviation is equal to 1, because again, I want this to be a standard normal distribution. So if I run that, now you'll see that runs again down in the console window. And up in my environment, I now have an object called y, which is 5 random and normally distributed values. So C is a function, R norm is a function, right? They're both sort of involved in data creation or data management. One of the other basic functions I'm going to show you right now is just the plot function, because then that's going to show us the functionality of that window down below. And the plot function takes two primary arguments, which are x and y. So in this case, I created a variable called x. So I want the x-axis to be x, and I want the y-axis to be y. And if I run that code, you can see that it gets run through the console window. And now rather than creating an object out here in my global environment, it's going to create a plot down below. So now here's my values of y. I've got 1, 2, 3, 4, 5 values that go with the values of x, which were 1, 2, 3, 4, and 5. Right, so any sort of two columns of data I could plot in this way. But again, this is just to kind of orient you to the different windows inside of the RStudio environment and some of the basic functionality of R. Right, hopefully you're already familiar with that, but a lot of the things that we're going to show you are going to have pre-written code. So we will give you script files where you can go through these things and you can just run the code kind of line by line rather than having to write a lot of your own code from scratch. One of the other things I do want to show you, though, is the actual installation of packages. So like we said, in base R, you have certain functions that are installed automatically. So, concatenate, the random normal distribution, the plot function, even this assignment operator. Those are all characteristics of base R. But if there are more advanced, more sophisticated things that I want to do, I kind of have two options available to me. Either I can program them myself directly using the component functions of base R, or I can go get a package where someone has already written kind of higher level functions that do more complex operations. So in order to install a package, so we're going to use the install packages function. So up here in my script file, I'm going to say install.packages, and then in quotes, I'm going to say tidyverse. And the tidyverse package is a meta package, which is to say it's a package that contains a bunch of other packages. And it's brought to you by the people at RStudio. And it's a super helpful package because it has so many different things wrapped up in it that are really useful for data management, aggregation, cleaning, data visualization, right, and creating really good figures. So Tidyverse has a lot of things in it, and some of the details we'll get into later. But it's basically the first package I recommend people install after they've installed R in RStudio. So let's go ahead and install that package. All right, that actually went reasonably fast there, but you can see, okay, package successfully unpacked and MD5 sums checked. And then we're prompted with this little caret symbol, right, that little arrow in the console window, which is the kind of the sign that R is ready for the next line of code. It has finished whatever computation it's doing, and it's ready to go. So this package has been installed, but that just means that it's downloaded and installed on our computer. To actually open it up so that we can use it inside of our R session, we need to use the library function. So we're going to say library tidyverse. And that might take a second to run. But what that actually is going to do then is it's going to open that package and import all of its functions into our current library. So that means that all of those functions will be readily available for us to use in our R session. And now this raises an interesting question about, why do I have to install it and then open it into the library? Why isn't it installation just always going to have that package be there? And the short answer is that packages are written by many different people. So functions will occasionally have the same name. Right, so a function from one package might share a name with a function in a different package. And if I try to open those both in the same session, one of them is going to get overwritten. And it's usually the older one is going to get overwritten by the newer one. So if I want to avoid that error and I want to stop that from happening, what I need to do then is only open the packages that I want to use in any given session, right? So by kind of having this two-tiered process where packages are installed on my computer, but they're not necessarily opened in my R session unless I specifically bring them in using the library function. That means that I'm never going to inadvertently think, that I'm using the filter function from one package when it's really the filter function from a different package. Because two different developers might have called it filter, but those filters might do really different things. So that's why we have this kind of two-tiered process. But once the package has been installed and then all the functions have been imported into your library, it's all ready to use. And so in subsequent videos, we're going to be talking about actually how to use some of those functions from those various libraries in order to perform statistical computations and do statistical analyses. So thanks very much for tuning in, and have fun running R.